7 perished. It was the worst catastrophe in the history of North Sea oil development.
Troll was one of the first projects to come after that disaster. So one of the things that we did immediately was to try and look at ways of reducing the destructive force if you were to have an explosion. And in order to do this, we made models that were about 1/12 the real size of the production modules and the wellhead modules. And we took these to the Pennines in the UK, and we conducted a series of 80 explosion tests there. And the thing that we did was to choose a very long, thin layout so that this safe haven of the living quarters is very much separated from the hazardous wellhead process and export areas on the platform. We've also put multiple barriers in here in order to get a fire barrier and an explosion barrier between the respective areas, so therefore compartmentalising, if you like, the hazardous areas.
The arms of the fjord open toward the sea. No longer hemmed in by mountains and narrows, Troll takes to the element for which it was designed. Yet another navigational hazard lies ahead on the route to the gas field. Troll draws 750 feet. A reef on the route is only 30 feet deeper. Troll should pass over the bar safely. But if sudden storm winds cause Troll to tilt, the skirts could strike the bottom.
We will monitor the weather very carefully when passing over this 1 mile shallow water, because the tilt of the platform is what really concerns us. The wind have picked up, but the weathermen have told us that around 11, 12 o'clock when we are passing this there, the wind will come down. You never know. Everything can happen. If we hit the ground hard and make damage to the skirts, it could be a total disaster. I cannot even see the consequence of what could happen. It could be a lot of concrete laying out here on the bottom of the shallow water, so it will be difficult for the next concrete platform to go out. But that's not what we're aiming for.
Yes, we are now just entering the shallowest part here, which will take us about 1 hour to get across. We are trying to follow this line here, and as you see, the tow is right on at the moment, just a few meters to the port. These are the 337-meter water depth line. We don't want to get into that. And Farsi, what are you reading?
We're reading 239, between 239 and 241.
239 to 241, thank you.
12.4. What is the tilt angle now?
Just 41 feet clearance under the 1,500-foot Troll structure. Troll advances further onto the reef.
11.1.
36 feet, shallower. The insurance representative can call off the attempt if he foresees imminent danger.
And you can see from the drawing there that we're just about halfway across the shallowest part of the tow route.
10.9 now.
35 feet, shallower yet. Finally, Troll passes the red lines into deeper water and safety.
It's very good. They have some 10-meter clearance.
It went well. There was no surprises.
We're all very happy.
In deep water and 4 days into her voyage, ballast engineers begin letting water into the air-filled chambers of the Troll, and the platform's slow and carefully monitored descent into the depths begins, even before it reaches the gas field.
We're now getting ready to start descending the platform. About 60 feet. We're doing this when they still are towing the platform. And this is the start, though, to put it on the bottom of the sea.
Here we are now, and the platform's just about getting ready to start the installation. The wind's dropping and the waves are subsiding. So with a bit of luck, we should be, by about 6 o'clock this evening, able to start the penetration.
At 1500 hours, we got permission to move in and go straight into the location. In about 1 hour, we will probably tack bottom here on this location where this huge platform have to stay for the next 70 years.
Take 7,
The game changes. The tug coordinator maneuvers his tugs into a star pattern around the troll. As the gas platform sinks toward the bottom, he must try to hold it in place over a predetermined position only 110 yards across. As long as the weather cooperates, the descent will continue. Once the troll's skirts have penetrated just 1 yard into the clay, its position can never be changed. The plotter displays the relative position of the multi-sided troll and the circular area onto which it must be centered.
Now have a clearance to the seabed of about 20 centimeters. We are just adjusting the position.
A touchdown anywhere within the 110-yard wide outer circle is acceptable. The target is the inner circle.
We have just came to touch condition on the port side of the platform, and we have now penetrated 10-15 centimeter. And the position looks very good at the moment, so we are ballasting down, continue ballasting down. But for the moment, we are in touch on 2 places, and we are approaching touch on the 3rd place. It shouldn't take long before we have touch all around the platform.
I'm a little sad because now it's going to the end of the project.
Troll is now irrevocably committed to a permanent position on planet Earth, just 19 feet from the exact center of the target area. During the next 5 days, the great weight of the troll forces the skirts 120 feet into the ocean floor. In her final position, the deck is 100 feet above sea level. There she is joined by a floating hotel.
We're putting together the final parts of the platform and hooking it up, and so we need to accommodate somewhere around about 600 people offshore. And we bring offshore then this thing down here, Flotel, sort of like a minor town or city where we accommodate everyone, feed them, look after them whilst they're working off here.
24 hours a day, this vessel performs triumphs of technical seamanship. It is not anchored, yet it maintains a precise position next to the troll. Against all the forces of wind, current, and waves, 6 thruster propellers, controlled by computer, hold the floating hotel within a few yards of the troll, never letting the 2 structures collide. A telescopic walkway connects them.
We tend to take it for granted, people walking across the walkway and working as normal, but of course this thing's under the influence constantly of current, waves, wind. It's constantly wanting to shift. We reckon we can be here with waves up to about 20 feet and stay on station the whole of the time.
Will be drilled 4,000 feet into the gas-bearing sandstone. The destination of the gas is a giant treatment plant at Kollsnes. From the ocean field, the gas must first be piped ashore under 2,000 pounds per square inch pressure to a terminal in the seabed at the base of a wall of rock near the coast. Moving the gas from there up the cliffs of the continental shelf to the treatment plant presented an enormous problem. The coastline of Norway is craggy, igneous rock. No pipeline laid on such rock could long endure. Some other solution had to be found.
The first challenge we have as a pipeliner is how do we connect the platform to the coast where the gas will be treated. It is impossible to build pipelines on rough rocks and rough terrain like this is. So we have a huge challenge. How do we get from this point to the shore, to the station where the gas will be treated? We have to make a tunnel from Kollsnes down to this part of the seabed, and we then make a hole in the seabed.
In 1991, as the Troll shafts were being built, a tunnel that would connect Kollsnes with the ocean floor was already under construction. A giant ventilating tube provides fresh air at the bottom.
Right now we're driving down to a point which is approximately 700 feet below the sea level, and as far out as 2.5 miles under the North Sea.
The unique challenge here is to find a way to connect the pipeline in the tunnel to the gas pipeline coming from the Troll field. How to find a way to drill a hole from the inside of the tunnel through to the seafloor without flooding the tunnel.
If you calculate the pressures that work on that little bit of rock that is still separating you from the sea, they're fantastic. The total force is something like 7,000 tons. To make the penetration between the tunnel and the sea, we fit the shaft out with concrete lining and already prepared a support that was going to be used later for supporting a big concrete plug. We then shielded the shaft bit off by building a big 8-meter concrete plug in the tunnel, a couple of meters from the vertical shaft. And then we prepared final blast, the penetrating blast between the sea and that vertical shaft. Two guys here in the tunnel, they lighted the fuses and waited for the things to come. Everybody else was out of the tunnel, of course, when the last penetrating blast was set off. So then the shaft was flooded, but of course the tunnel could not be flooded. The concrete plug was sealing it. Then with a big crane we lowered a prepared concrete plug with pipeline ends sticking through it. That was lowered onto this prepared seat in the vertical shaft. And it was grouted up. After letting it cure for a couple of weeks, we very, very carefully opened a little tap to see if the pressure behind the plug was dropping. And yes, it did. That meant that we could drain the area behind the shaft, remove the plug, and from there on we could construct the pipelines in the tunnel.
While work at the tunnel continues, an entirely different operation is underway only a few miles offshore. A chartered vessel, the Castoro Sai, is laying down the two pipelines that will convey the gas from Troll to the Kollsnes treatment plant. From Kollsnes, pipelines will deliver the gas to Europe. The 500-foot-long Castoro Sai is essentially a floating factory, mounted on top of 10 shafts that are supported by 2 submerged hulls. Secured in place by 12 50,000-pound anchors, the vessel trails out pipeline by slowly winching forward on her anchor cables while letting out the cables astern. On average, Castoro Sai lays 100 sections of pipe a day, adding up to 1.5 miles of pipeline. Work on the pipe-laying vessel never stops. It keeps the assembly line going 24 hours a day.